Hello everyone and welcome to JP Creation. In the previous lecture we saw how to view color channel and this will be useful in how much wider a color is present in any of the image or sequence. So if we think about the human eye is particularly sensitive to the green part of the visible spectrum due to evolutionary adaptation. So our ancestor developed better perception of green light because it is mostly abundant light in the environment. So predominantly green, which will help them in identify object and such. So this sensitivity of green light is actually mimicked in the digital camera by what it is called a Bayer filter. I will show you the Bayer filter. Select the image and press 1. This is not a higher number of let's say photosynthesis on the image sensor, but there is a sort of filter placed over the camera sensor. So if you are using like a DSLR or something, you know behind the lens there is a camera sensor that's capturing the light. So in the Bayer filter, half of the filter are green, uh, with the remaining equal divided between red and blue. So you can see the green color is more 50% in the sensor, and rest blue and red is by divided by 50. So you will get the less number of blue and red color in the overall sensor. This configuration helps the camera to capture more luminance information and deliver greater details in the image. So producing images that took more naturally and pleasing to just like a human eye. So it's kind of mimicking the human eye by capturing more green and kind of using that in the that to create more luminosity or luminance in the image. I will also show you the second image which I have here. You can take a screenshot of this image. In this also you can see that we have three channels here. In the green channel you get 50% of the color from the green channel, but from the from the rest red and blue you only get some of the light which is divided between the both the colors. So this is called Bayer sequence. You can take a screenshot of this. So if this is how we can see the light, meaning the brightest part in those sort of greens and yellow. I suppose on this graph, and this is the visible light spectrum. So everything beyond this color are invisible, but this is the brightest part of the eye. This is why it's useful to understand when we start talking about green screens, because greens are going to appear at the brightest on the camera sensor, and it's actually opposite of the color that are trying to actually we are going to extract the opposite color. And what is those color? It's actually a skin tone. It's the sort of orange and yellow tone that we see on the people's face sometimes in the case, but not in the opposite side. It's usually not right next to the green. So we need to separate those two colors like from each other by targeting the section. Like if you target this section and then target this section, both the types of green, you can remove both the types of green. And that essentially what keying is. We are just targeting different section of green, and if it's not a perfect green screen, we might target one section of the green or another section of the green and combine that both keys together. But the fundamental, the description is here. So it's bright. it's brighter to the camera and it's furthest from human skin. So that's why green is typically used. Now sometimes blue screens are used more often for nighttime sequence, but blue is just a little bit darker to the camera, and that's most often where blue screens are used. But there are other scenarios also in which blue screen are used depending on the clothing people are wearing and such, but most often we are dealing with a green screen, so that is how it applies.